Hi guys, I'm Yuation and today I'm gonna tell you guys an article I read, which is pretty cool. It's called a new carbon negative material that could make concrete and cement more sustainable. So, right now, global warming has a main cause for many problems, and therefore we want to get rid of the CO2 or capture it to maximize its value. And in this article, the researchers had developed a new material that is carbon negative, meaning it removes electron from the atmosphere more than it emits for its production. So a summary of it is you make it into solid and you use that solid for the construction of things. So traditionally, the material production contribute to 8% of the global carbon dioxide emission. However, by using this method, it decreases significantly the carbon footprint. It is indeed a significant step forward in sustainability, and I will mention why. You guys gonna know why later on in the video. It is a method of increasing the pH of the sea that, in one hand, maintain a better marine life as well as get rid of the carbon dioxide. So the top image show the ideal case for the water of the sea, and the bottom shows a not so ideal case because it had low pH. So we start off by having carbon dioxide and water. They go together and become carbonic acid. And due to the pH of the water, it will becoming bicarbonate because carbonic acid is like strong acid, and the water it is not so acid, so neutralize that out, so that become bicarbonate acid, and then that's where things are getting a bit complicated. So it could become bicarbonate acid, and it could just stay bicarbonate acid, or it could become carbonate. So if the acidity of the water in the sea is pretty low, which means it's acidic, it will stay bicarbonate. However, if it is like more base that want to neutralize that out, so the H2, so the bicarbonate just get neutralized out and then become carbonated because the hydrogen ion is acidic. And therefore the carbonate is going to be added up with the calcium. It's calcium and the carbonate that form calcium carbonate, and that is good for the for construction materials, and it can help coral and shells to form their skeleton structure and neutralize acid. And this is a demonstration of electrolysis, in which only the cathode is applied here. We don't care about the anode, but I can tell you guys how the anode works. So the K in the cathode, the cation, okay, the cation, it get attracted to the negative, yeah, and gain electron, and the anion move towards the positive, which is anode, and make it lose electron. So basically, what happened in the situation that the cation in the H2O is basically H2, and H2 just get close to the cathode, and then they become a hydrogen gas, and they leave. And then the hydroxide is what is left over with, and by adding CO2 gases through the seawater, so it can increase the concentration of bicarbonate ions. I'll talk about that later on. The cathode, the negative electrode. So that's the top one is like the chemical reaction 2H2O plus 2E is get you hydrogen gas, which is H2 plus 2OH. So it is a production of hydrogen H2 gases as well as hydroxide ion, and the hydroxide is pretty interesting because it can make the surrounding water slightly more basic, which more alkaline in another way to say it. Now you guys gonna think, right? Very normal. Why doesn't the Na form bond with the OH? Very good question. It does form, but it break, but it is very soluble in water and in aqueous form, and bam, it just break. So it forms, but deform very quickly. So the formation of carbonate, yeah, carbonate. So remember, all right, the CO2 it do not form up with OH. It has to form up with H2O. In first place, it has to make up this thing, H2CO3, which is carbonic acid in first place. And then from the acidity of the water, and this step, in the second step, you can add OH. Imagine you have a OH to balance out that extra hydrogen ion so that it become a bicarbonate ion, because the OH it makes the water surrounding water more basic, and so balance it out. Yeah, and technically that is also the same thing for HCO3, because the surrounder is more basic. You have an OH, and then it just becomes CO3 plus H2O. And then finally, we got the formation of CO3 and MgOH. I know you guys have questions, a lot of questions. Why not MgCO3 and CaOH instead? Well, in fact, it depends on the solubility of the compounds that we didn't learn yet. The higher the value of the solubility, the more soluble and more likely to it gets dissolved easily. Like, because the solubility is like a amount of things that can dissolve in water. So higher the amount, it dissolves more easily. And lower the value, that means it is less soluble, and it is more likely to form a solid. It is more likely to form a solid. That is very important. So basically, what we're seeing here, finding here, is basically we want to find the low value, the low value. So you guys can see the MgCO3 and the CaOH, they got high values. That means they dissolve more than the CaCO3 and the MgOH right here and right here. And therefore, we have to take the values of two compound with the low solubility. And so that's a formation of it. And CaCO3 is commonly used in the construction industry. Also, it is generally in its processed form, such as limestone, marble, or chalks. And here's the source. If you made it so far, thank you very much.